Welcome to my process book. In this video, I will showcase my project in digital fabrication. In this course, we were tasked to design and produce a multi-material artifact that integrates multiple fabrication modalities, with each component fabricated using a distinct technique. This video will serve as my process book to show my research, insights, and process in creating my physical artifact. Let's jump in. The goal was to create a physical artifact with the following fabrication techniques. Woodworking. Make a 5-sided pedestal 11 inches by 11 inches by 11 inches max. Metalworking. Make a corner detail connecting foam to wood using the supplied metal. Think about the hardware or the attaching method. Must contain at least one fold or bend post printing. UV printing. Print a graphic illustration on the metal corner detail. 3D printing. Print a feature object. CNC milling. Mill foam to receive the feature object and intentionally meet or relate to the wood pedestal. Laser cutting. Make an information tag. Minimum your name, semester, class info, faculty/TA name. I will go into more detail on each technique later as I showcase my work process. I started my research process by sketching ideas for my artifact. I like Japanese-inspired artwork, so I started to look into Japanese patterns, specifically the Wag-era patterns. In my first iteration for the artifact, I planned to create a Japanese tanto or dagger in its sheath. Turns out the design and technology lab doesn't allow 3D printed weapons, even if it was decorative, so I had to pivot my idea. By week 2, I learned the exact dimensions that we were recommended to work on, so the dagger idea would not have worked anyway. My second idea sketch was to repurpose a lamp that I have at home. This lamp can use the wooden box as base. The foam can hide the lampstand and wires. I will then 3D print a lampshade with a hole at the bottom for the bulb. For metalworking, I plan to UV print the Wag-era patterns on the metal and fold on the corner for accent. Let's break down how each technique was designed, starting with woodworking. For my wooden box, I wanted a perfect cube for my 5-sided pedestal. Since I was a total beginner with the table and bandsaw, I knew I should not make it too small when I was planning my cut list. I ended up with 4 pieces of 8 by 8 inch square pieces and 1 piece for the top with 8.45 inches. This additional allowance will help me when attaching the sides of the box. I can then just sand down the excess to form a perfect cube for my wooden box. I used the table saw to make my vertical cuts and used the bandsaw to make my horizontal cuts. These burn marks you see on the edges of the wood are due to the speed in which I pushed the wood through the table saw. I was too slow when pushing out my wood planks, that is why it has burn marks. To avoid this, when using a table saw, push the wood forward continuously and do not stop until the cut is complete. Now that I have my wood pieces, time to attach them together. Since I didn't account for the wood's thickness, I had to adjust my box for it to be a cube. Instead of 2 wood planks on each edge to make it look symmetrical, I had to put each plank over the edge of the next plank to make it a perfect cube. If you look closely, you will see what I mean. I ended up with an 8.5 inch by 8.5 inch by 8.6 inch box. I used wood glue as my adhesive to attach each side of the wood to form a box. I also used a nail gun on each corner for durability. I waited for 1 hour for the glue to cure. Once cured, I sanded down the wooden box using a palm sander. After the palm sander, I used a 600 grit sandpaper and sanded the wooded box's surface even more until smooth to the touch. Onto metalworking and UV printing. My idea for the metalworking portion of the project was simple. Cut 4 pieces of 2 inch by 2 inch metal squares. Cutting the pieces was easy. I used a sheet metal cutter and set the cut length to 2 inches and did it on both sides of the sheet metal. After cutting the metal pieces, I deburr the metal plates to remove sharp edges using a deburring tool. It is important that you sand the surface of the sheet metal before UV printing. I created an Adobe Illustrator file with my intended design. The key is to make an outline layer with just the exact size of the artwork and add a bleed area so that the print will cover the surface of the metal sheet. In hindsight, I should have sanded my metal sheets more to make it clear of any stain or marks. The shinier it was, the clearer the print was. To fold the metal sheets, I used a metal press. I covered the metal pieces in tape to avoid scratches during folding. I placed the metal sheet diagonally and folded all 4 metal plates into small triangles. I was going for a 90-degree angle on the metal plates. The tape protected the metal plates from scratches, but also peeled some of the edges of the design. Remember to peel gently or just use a rag instead of tape. I attached the metal corner pieces into the wooden box using quick dry epoxy. Now we can proceed with 3D printing and CNC milling. Since I was going for a lamp as my artifact, I used Thingiverse.com to look for 3D printed lampshades. I grabbed a twisted cube design and adjusted the measurements accordingly based on the actual size of my wooden box. I used white PLA for my 3D print. CNC milling was the hardest part for me. Modeling in Rhino 3D was challenging. My design idea was to fit the foam inside the 4 triangle metal corner pieces. I ended up with an octagon shape for my foam midsection. A cylinder shape was subtracted from the center of the foam model. The cylinder has the same diameter as my lamp. A half tube was also formed at the top of the foam model in order to subtract a space to run the lamp cable. Running the cable through the foam enabled me to not drill a hole in the wooden box anymore. I instead used the free space inside the box as a small bookshelf. To attach the 3D printed lampshade to the foam block, I used the lamp screw lock for the bulb and attached it on the lampshade while the lamp and the cord is embedded in the foam block. To attach the foam block to the wooden box, I had to make manual adjustments to the corners of the foam block. Since the metal corner pieces bended with a curve, it made the foam block too big to fit inside the corners. I tried sanding down the foam for hours, but the curve in the metal bend was too much for me to adjust the size by sanding. I drew triangles on the sides where the corners would fit, and using my thumb, I pressed slightly on the foam. It wasn't the cleanest solution, but it did work and made the octagon foam fit the metal corner pieces. The last and easiest part was the laser cutting portion to create an info tag. I used the Illustrator template to design my tag. I followed the instructions on the template, and I was able to cut a small 2.5-inch by 4-inch acrylic info tag. I did this by creating a layer using a red hairline stroke. I was able to do linear engraving with more Wagera patterns on the acrylic tag using a blue hairline stroke in a separate layer. Lastly, I was able to rasterize the acrylic with my information by using a black fill in a separate layer and converting text to outline shapes. My Lightbox desk lamp is almost done. I plan to do finishing touches to it. I plan to put wood stains on the wooden box. I plan to paint the foam black. I also plan to paint the rastered and engraved parts of the acrylic tag. That is why the protective peel is still on the acrylic. Here's some B-roll of my Lightbox desk lamp. Please enjoy.